Hello, welcome back to Cracking the Cryptic, and we've got a puzzle about weather today. Thunder Snow by Refrigerator. I will get through the rules in a moment. I will go to the rules in a moment, and we'll have a go at getting through the puzzle if we can, getting through the storm of this puzzle. But before that, I do want to quickly mention that you can join us on Patreon, where there's extra content, Sudoku hunts every month. Brilliant one coming up on the 1st of September. There are solution videos for previous hunts. There are extra challenges, crosswords, and connections videos. So do have a look at that. What else have we got? We've got all of our apps, which do feature line Sudoku and domino Sudoku, relevant to today, and also Fog of War and the marvelous Worms. And you can go to Sven's Sudoku Pad on the link and support Sven in the marvelous development of this incredible software with which I will play this puzzle. Now, Refrigerator says there's terrible weather out there. Stay warm, folks. Now, he's not talking about my country, because we've had what is, I think, universally acclaimed to be the best summer in many years. And best in the sense of really warm again and again, 4 heat waves or something, and they haven't been too hot. I do remember the visit when we were at the Crossword World Championship. Phil from Australia was there, and he said, "I'm from Canberra. I hear you're having a heat wave," and he just shook his head, like to indicate, by other people's standards, your heat waves are not hot, and I believe that is true. Anyway, that was fun, but there must be some bad weather in the world somewhere, because Refrigerator, who has a name that sounds a bit like freeze or fridge, is suffering from it. And we've got lightning and entropic wind and as well as, of course, Sudoku and snow and cloud in this. So I will explain the rules now. Normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box, just to keep Mark happy. Now, lightning. Adjacent digits on a gold line differ by at least 6. Well, that's one more than the German whisper. So maybe it's a Texas holler. I can't remember quite what that was. But on an entropic line, on a peach line, these are the ones that are more horizontal. So they're wind, of course. A set of 3 adjacent digits, like those 3, contain exactly 1 each from the sets 1 to 3, the low digits, 4 to 6, the middly ones, and 7 to 9, the high ones. And then, well, the white and black dots have been given some thematic context. The white dots are dots of snow, and they, as usual, mark consecutive digits. The black digits are black clouds, and they mark a 1 to 2 ratio. Not all possible weather is given, meaning there could be other dots that aren't marked. Right, those are the rules. They're relatively straightforward. I struggle a bit with entropic because I'm always thinking about modular lines when I'm meant to be doing entropic lines, but we'll see if I can clear my head for once and attack this properly. Let's get cracking. So, the first thing I'm going to observe about the lightning bolts is that you can never have 4, 5, or 6 on a line which has differences of at least 6. You've got to be confined to 1, 2, 3, 7, 8, 9, because 4, 5, and 6 just don't have relevant Sudoku neighbors. So this digit on a black dot can't be 7 or 9. Now, we're going to alternate between high and low. There's no problem with that as you get bigger than 5 as a difference. So let's take the longest line first and say we're alternating between high and low. Is that going to tell us anything there? That's going to be 1 of each on that line, but we can't relate them to the green and pink I've made up for the first line yet. So I'm not keen to delineate those. Oh, I see. Where we cross these lines... yes, it's always going to be right. The thing about these entropic lines, and the same would be true of modular lines, is because every set of 3 has 1 of each category. then every third cell has to be the same entropic set, the same of 1, 2, 3. So what I'm saying is, if this digit was 1, 2, or 3, these would have a middly and a high digit in, and for this set, this would have to be low again. Now, it is nice that in this puzzle, the high and low in terms of a lightning bolt overlap, coincide exactly with the modular sets. So if this is low, it's 1, 2, 3. And that would mean these two are low, and the same if they're high. So we can therefore colour those lines, which are 3 away from that. And now we can do our full alternating shading along each of the lines and know that we are consonant with the long line. We still don't know whether purple is high or low and green is the other. Well, we don't know if purple is high and green is low or vice versa, but we do know that we are matching because of this line, which is the only one that connects all the lightning bolts, I now notice. I hadn't really clocked that before. Now, are we beginning now to get some idea of... It's going to be the black dots which are going to decide our modularity. No, our entropy sets, our polarity. The black dots, if it wasn't for them, if there were no black dots in this puzzle, it would have at least 2 solutions, because you could take the final correct grid, subtract every digit from 10, and you'd have a final correct grid again. But the black dots will spoil that. The white dots wouldn't, but the black dots would. Right, these two are in different entropic sets. So they're not 1 and 2, which would be in the same one. That's not actually very helpful. Okay, I still don't, I mean, I've managed to connect all the lightning lines, but I haven't actually done anything else in the puzzle. Okay, now normally when we do a German Whispers puzzle, I tell you 3 things. I tell you 5 can't be on it. Well, I've told you 4, 5, 6 can't be on it this time. I tell you we must alternate, and we've clearly done that this time. What I also tell you about is monogamous digits. Now, there are monogamous digits in these lightning lines, but they're not 4 and 6. They are 3 and 7. And they cannot occur in places where 2 neighbours are the same. Where 2 neighbours see each other. Like this cell has these 2 neighbours that see each other. So that can't be 3 because they both have to be 9. Right, let's find the cells where 3 and 7 can't exist. I think on this line, only that cell is in this category. On this line, there are more. That one sees 2 in the same column. This one, not the next one. That one sees 2 in the same box. So there aren't many of these cells this time, but there are some that can't be 3 or 7. And now we have a pair of greens there that are either a 1-2 pair or an 8-9 pair. And we have that on the line. That is a purple on a line, on an entropic line. And that means for these 2 cells, one of them is green and one of them is our unknown colour, which I'm going to probably make yellow for middly. What I want to do is find somewhere where we've used up all the possibles, like 4 purples, 4 greens in a row, column or box. I'm really not getting that. Oh, green must go there because that's 3 away. Now, maybe there's an issue with purple, purple, purple. Is that impossible? This is quite interesting too. On a white dot, you're either going to get 2 of the same colour or an extreme colour like green or purple together with a yellow colour. Because the white dots are either going to bridge the gap between the middly digits and the more extreme digits, or they're going to be confined to one category. Now, I still haven't got a break in here, really. I mean, I've done a lot of work and I have not got a break in. That's quite weird. So this cell is either green or the nearest digit to green that is yellow. Let's imagine green was low. What I mean is this cell is either 1, 2, or 3, in which case it's the third green in the box and the row. And that's impossible because there has to be a green on this entropic line. So this can't be green. So this is yellow. If green is low, that's going to have to be a 4. If green is high, that's a 6. This is now a 3 or a 7, which I would thought, well, we'll have possibilities of eliminating 3 or 7. I didn't realize we were going to find cells that were 3 or 7. That's interesting. Okay, well, that was a good spot. Now, what I was going to do was say, if that's green, this can't be double green. And that would not only wouldn't have been true, it wouldn't have been helpful. Okay, this set has one of each because they're 3 consecutive lines on a peach. And that's going to use the third green in the box, another purple and another yellow. So these two are left to be, a purple and a yellow. Now I know what this is because these 3 have to be one of each. So they must include the third purple in the row. So that can't be purple. And now that is purple, and we can purple that over here because of it being 3 away from this. This must be yellow to complete the line. Now we're filling up, I don't know, if we increase the filling upness of the central column? Not really. This can't be double green because we'd have 4 in the box. It can't be double purple because we'd have 4 in the column. So at least one of these is yellow, and it might be both of them. Okay, I'm beginning to get somewhere. This is a group of 3, so that's one of each. So we can count this whole row and say that that's yellow. Now, in this box, we've got one of each there, one of each there, and therefore we're left over with one of each here. So these are a purple and a green in some order. We count the row again, and that's yellow. Now we count along this line, 1, 2, 3, 1, 2, 3, that's yellow. Okay, we're gradually colouring in entropy. And maybe this is the way to do it. Now, one of each there. One of each here is going to use green, so that's the third green. That can't be green. This is now green, and we count along here, and that's green. This must be purple, and that must be purple. And once we've had purple, yellow, green here, we're going to have yellow and purple over here. And that's going to leave green and yellow in these 2 cells. And I don't know which is which is a pity. Oh, if that was yellow. That's quite an interesting thought. Okay, these are a purple and a yellow in some order. If this one was yellow, it would be the third yellow in its column. And that couldn't be yellow. So this yellow would be 4 or 6. This digit would be 3 or 7 on a black dot. If it was 3, that would be 6. If it was 7, it would be impossible. So if this is yellow, we have broken into which is high and which is low out of green and purple. But if it's not yellow, that's yellow. And that's a little bit more open to interpretation. Then this is purple. That's either going to make this purple or a yellow 3 or 7. No, a yellow 4 or 6. Oh, they're both doable. Okay, I maybe that's not the place to go. It looked a bit like it. What about this row with 2 white dots in it? If purple is on a white dot, it's with yellow because 2 purples have been used. No, I don't know. That's not It's not getting anything done. Right, there's a green here, isn't there? I've just worked that out. This is yellow and green because that's purple. And that's going to be the third green. I'm actually going to mark them as a yellow-green pair. Now, if the green is here, I don't know. All I know is there's no green there. Okay, sorry. That wasn't quite the conclusiveness I was hoping for. Oh, gosh, I'm struggling along a bit. Now, that could be green if this was a 1-2 pair. Otherwise, it's yellow. I don't think you can have green, purple, one from high and one from low. So this digit is either green or yellow. That's not getting anything done. How about this pair that can't be double purple because it would be too many in the box and column? That can't be green. I don't know. Feels like, again, it's very interesting, but I don't quite know how it maps out. This cell. This cell is green because that has been stopped by this from being 3 or 7, so it can't connect to yellow. Okay, well that might be interesting somehow. If I can just work out how, that would be nice. This is green. Is that sort of thing available anywhere else? Have I got 1289 written into a white dot cell? No, that's the only place. Interesting. That feels like a little harder deduction than usual. Now, what does it say about these white dots? Does it say anything? We've got one green, purple, and yellow up here for this line. Oh, and we know that's purple and yellow as well. So these two must be able to work it out. There's a green and a yellow in these two. Now, if that was green here and yellow here, it would be very constraining. That would complete all the yellows in this column. More importantly, perhaps, it would complete all the greens in row 2 and column 8. Oh, I mean, it would be very helpful if that was green and that was yellow. This green would have to connect to a yellow here. So that green would be the 3-7. The yellow would be the 4-6. I chose not to use placeholders. I'm almost beginning to regret it. No, I don't think I am because it's really going to matter what goes on the black dot. Anyway, if that was green and this was yellow, 3-7 here. This would either be a 1-2 pair or an 8-9 pair, and so would this. This would be double purple. If that was green and that was yellow, all the yellows are used up in column 9, so those two are going to have to be the same colour. And they can't be green because we'd have had 2 greens, so that would be double purple. This would be... I feel like that would be yellow. I don't know if it matters. I just can't work it out. A bit too much going on for me to work. Oh, hang on. Here's a thought. Right, again, if this was green and this was yellow, because that is a green-yellow pair, we know this. I'm actually going to mark them now. If this one was the green one, those three greens would be used up. That would be yellow. That would be green. The third green would be here. That would be yellow. And this would be a 3. So if this is green, that's a 3. Green is low if this is green. And then these are both high. And that is, well, that's a 3. So this isn't a 3-6 pair in this situation. So these high ones have to have an 8 up here. It doesn't work. It doesn't work. Okay, I mean, it's a bit complicated, but I'm going with it anyway. And placeholders might have made this clearer, but I'm going with it without placeholders, and I'm going to explain it all to you. So if that was green, right, let me just get this straight in my head again. If that's green, this is yellow and that's green. There's got to be a green there, so that's yellow. Now, this is unable to be 6 because that can't be 7. Oh no, this is a black dot. I've been thinking for a moment it was a white dot. I've messed up. Oh, bother. Okay, I thought I had figured it out. Now, let's try again. Let's just man up and try again. If that's green, this is yellow and that's green. This is not green. This is yellow, but unfortunately, that just means it's 4 or 6, and this is 2, 3, or 8. That doesn't really tell me all that much. Okay, I've flubbed there. Okay, this here's an interesting point that I haven't thought of. One of these two is yellow because they are from different entropy sets based on the line, and yet there's a black dot. Well, they can't be 1, 2 because they're different entropy sets. So they're either 2, 4, 4, 8, or 3, 6. And in all of those cases, there's a 4 or a 6, a yellow digit in one of those two. And this one is not yellow. This is green or purple, which is the last one of its kind in the column. Now, what is that telling me? That's got to be telling me something, surely. This is a yellow-purple pair. Wow. I mean, I suppose that could still be double yellow. That's really weird. These are diagonal pairs. Okay, I don't know. That's green. Yellow's in one of these two. If that was yellow, that is double yellow. Okay, let's go back to this column where we've got 3 yellows still to place amongst these cells. Now, in one case, we're going to use up all the yellows in the box. If those two are both yellows, this is going to be a double purple. Okay, that's quite interesting. So if that's, I don't know, maybe it doesn't get anything done. Oh, I'm so close to finding some way through this. It's a very, very interesting puzzle. Oh. If this was purple, this is either purple or yellow. Ah. Oh, bother. I was going to say, if that's purple, this must be double yellow, but that's not necessarily true. Yes, it is true. Okay. If this was purple, this is double yellow. I know it's not yellow-green because the 3 greens have been used up amongst those 4 cells in the box. So if that's purple, this is double yellow, and that's green. If this, on the other hand, is yellow, all three yellows have been used up in this column, and that's green again. So that's always green at the top. And this is now, therefore, yellow here. Now, green has been used 1, 2, and there must be a green on this line. So that's not green, that's now yellow. And that digit is 4 or 6, can't be 5 on a black dot. So we've either got 4 or 6 used up there. Over here, we're also going to use 4 or 6. Because this black dot with different entropies, again, well, it's either 4-2, 4-8, or 6-3. So we're going to have used 4, 6, and 3 in these cells, definitely. One of them is a 6-3 pair, and one of them is 4, going with either 2 or 8. So that's not a 3. Now, come on, what does that mean? That was progress. Why is it giving me nothing? Oh yes, green and yellow have been resolved along this line. So now I know that's yellow. There's a third yellow there. So this isn't yellow and it's not green. It's purple. That's the third purple in its column. So this is a green-yellow pair. Is that any good? What about this box? We've had 3 green and 2 purple. Ah, where's the third purple in this column? Oh no, it could still be there. Bother. If the third purple is here, it's a 7 going with a 6. Then that couldn't be 7. If, on the other hand, that's double yellow, then that's purple. No, I don't know. No, that wasn't it. Oh, good grief. Right, in this box, we've got 2 yellows, 2 greens, and a purple. This cell sees 3 greens in the row. Oh, there are 3 greens in the row, so that's not green. That's yellow. This now, I was going to say mustn't be yellow, but I don't know that. That could be a double yellow, couldn't it? Oh, forgot that. Oh no, this was in a pair with that, so that's green. Okay, that's interesting. That's interesting. We've got a green cell here. Okay, neither of these can be green because we've had 3 green in this box. So one of those is green, and that's going to make up the third green. So this is not green. Does it see 3 yellows or 3 purples? No, I don't think it does. I curse again. Okay, what about this white dot, which can only have a maximum 1 green or 1 yellow on? But it could be green-yellow. I do think there's something I'm just not grasping about the connections. But, you know, I'll get there in the end, I feel. Again, here, we've had 2 yellow and 2 green and 2 purple in the column. That's quite interesting. No, we haven't had 2 yellow. We've only had 1 yellow. So this could be double yellow. This digit can't be green because it's next to a green on an entropic line. All I know is there must be yellow in one, at least one of these two, but they could both be yellow. Ah! Oh dear, I'm really working myself into a frenzy here. Just can't quite get through. That's a yeah. Oh, in this row, this is blindingly obvious, perhaps. I don't know if it's going to yield anything, but that's a yellow purple. That's a yellow purple. This has to be one of each. And we've had purple. So this is a yellow green pair. That's going to use the third green in the box. So this digit can't be green. It's yellow or purple. If that is green, this is yellow and is the third yellow in the column. If that is yellow, it's the third yellow in the column. And this is never yellow. So this one, which was on the diagonal with it, becomes yellow. Now we can colour this whole line all the way along. 2 more purples, 2 more yellows. This is going to get us all of our colouring done, I think. So let me figure out how it does that. Because that was huge. And it was just from observing that we had one of each there, one of each there, and therefore one of each here. I should have spotted that ages ago. But we've got it now. We've got it now. Now, we've got 3 purples in this column. And 3 greens in this box, so that's a yellow. This now goes with a purple in one of those cells. Could have done that by counting the column. And therefore these digits, well, do excuse me a second, I'm sorry. Right, apologies about that short break for me. Now, we were just I was getting excited. I know I was, I can't help it. I've just got a spot where three of a kind is always happening. Now, one of these is yellow. They can't both be yellow because of this column, and one of them must be yellow because the other is purple or green. They can't both be purple or green, which is amazing. Is it true? Yes, it is true. Because we've had the 3 greens in this box. Okay, good. One of those is yellow. So this is not yellow, but we need a yellow on this line, so it's there. That's 4 or 6. This one, come on, don't know. But we've had 3 yellows in this column now. 2 greens. Oh, this is touching. Right, it can't be yellow and it's touching a purple, so it's got to be purple. Right, so this one is green. Now we've had 3 greens in this column, and that's not green, and therefore that's not yellow. Now that's green, this can't be purple. That's yellow, we can count this column, and that's purple. Good. This sees 3 greens in the box, actually 3 yellows in the box as well, so they're both purple. This can't be purple because it sees 3 purple in the box, so that must be yellow to be touching a purple. We've had 3 yellows in this column, that's green. And there's no purple here. Oh, these 2 are too yellow on account of this column, so that's green, that's purple. Right, we're moving along. These ones are a green and a yellow. Is there some reason why either can't be? Oh, I can count. No, I don't know which way around those go. Okay, this digit sees 3 purple in the box and row. It's either the 3rd yellow in the column or the 3rd green in the column and the row. I don't know. I mean, maybe I should do the numbers. Maybe I should try and work out what's going on up here. So if that one of these is a 3, one of these 2 is a 3. This is 2, 3, or 8. One of them is a 3. I don't know what this means for me. Somehow I've got to relate this to the white dots and crack it through. There's a 5 in this pair. that digit is 4 or 6 because it's yellow touching, right. So the 3s or 7s, yes, yellow touching another color on a white dot means 3 or 7. So this pair doesn't have a green 3, 7 in. This is also more extreme. These are quite extreme because they see that can't be 3 or 7 purple either because of this. Now, this can't, oh no. I was hoping it couldn't be 3 or 7 in its color, but that it was looking at a green 3 or 7, so that didn't do anything. Oh, this is a 3 or 7 in the column. Strange, and it's probably not. I could have worked that out earlier as well. These are from 4, 5, 6, and they include a 5. There is a 3 or 7 in one of those. If it's 3, it's not there because 3's been used in the top row. That's weird when numbers actually come into it a bit rather than just extremes. That's 4 or 6. One of these has a 5 in. This is yellow and purple. So that includes purple's 3 or 7. And therefore that's not a 7 because it's purple. And this is not 3 or 7, partly because that's 3 or 7. I should have used placeholders, shouldn't I? Anyway, we didn't, made that decision. Purple 3 or 7 is there. Purples are all done. 4 and 6, 4 and 6. Look, I can put a 5 in the central cell of the puzzle. It is intriguing how often in beautifully symmetrical puzzles, you often find a 5 in the middle for magical reasons. This one is not so magical, but it is still magical that that's the first digit I get in the puzzle, is a 5 in the center. That's 4 or 6. This is a 5. That's 4 or 6. This is 4 or 6. Now, this could be 5. In fact, 5 is in one of these two cells. I've got a 4, 6 pair in this column. Don't know what that means. 5's in one of those, one of these. Oh, 5 in the top row is there in the corner. Didn't see that coming either. One of those is a 5. That's weird pencil marking in this puzzle. When am I going to get an actual breakthrough for the polarity? What am I, 35 minutes in? I still don't know that. One of these is 3 or 7. This is not 3 or 7, nor's that, because we've got green 3, 7 in the box. Right, so green 3, 7 in this column is up at the top. There is the breakthrough, because 3 must have been used in one of those cells. So this is a 7, and green is high, and I'm going to turn it all blue now. No, it's high. I'm going to turn it all, let's make it red for contrast with the yellow, and I'm going to turn the purple blue. And there we go. So red is high. That's an 8. Oh, let's get it in the right mode. This, oh my goodness. Okay, let's go through making red high. Okay, that's all the red made high. Let's make blue low. Now let's do these numbers in the top row. 8 goes with 4. That must be 6 and 3 in the corner. That's 3 in the corner. This must be 2 it's connected with. Right, and we're looking for 3, 2, 1 in blue. So let's carry on with making them 3, 2, 1 where we can. There's a 1. That's a 1 or a 2. This is 3 and 4 on the dot. That's a 6. Okay, that figures. That's a 1, 2 pair. Apiece 7. In fact, we've got a 1, 2 pair in this row. That's 3. Now, by the rule, that means that's next to 9. I've barely used the whisper rule at all here. That's a 5, 6 pair. We'll resolve them soon. These don't have a 6 on. That is not 7, so that's on a white dot with that one. So 8, 9, 8. Maybe I won't use the whisper rule. Maybe I'll just use Sudoku. 8, 9, 8, 9. That's all flowing together. That's got to be a 9 by Sudoku. Never afraid to use a Sudoku technique or two. That's an 8. We'll colour that. For once in this puzzle, I'm not vaguely thinking about uncolouring it. 7 and 8. That digit is a 9. We need a 7 in this row. Okay, I don't know about that. Let's look at this. That's a 4. Oh, I thought that was going to undo all the yellows, and it absolutely didn't. That's a 6. That'll do it. That's a 4. That's a 4. This is a 6. How come these aren't done? That is done. That's a 5. That's a 4. That's now 6. That's 5. That goes across here, 4 and 5. Right, down here we've got 6 and 5 to fill in. Bottom row, I don't know, that's 2 or 3. 1 or 3, that's 1. Oh, this sees 2 and 3, so that's a 1. And that is going to help with the blues. Yes, I can see that's 3 now. That's 1 or 2. But we've now figured out that row 8, column 2 is a 2. That gives us 1, 2. That's going to go across the grid. 1, 2, 1, 2. Oh, such a relief, flooding over. 3 and 4 can be done there. I should colour them, shouldn't I? Because they're part coloured at the moment. Now, down here, we've got 3 and 4. Yes, we do know which way round they go. And again, I can correct the colouring. What's this? It's got to be 1. Right, 6, 2, 3, 7 here. They must all be done. They are. That's a 7. That's a 5. That's 6. Looking up the column, 7 and 4. That's a 5. That's a 7. Right, before I put in the last digits, let us colour away like a demon. Middlies, lows, and then this final cell is yellow and is 6. And there we go. That is the Thunder Snow resolved. Congratulations on finding shelter. It's a very clever puzzle by Refrigerator. I think I made a bit of a meal of it, but I just couldn't get the polarities right up here. For ages and ages. I couldn't resolve them, basically. And that is often the joy of these colouring puzzles, is you put off resolving exactly what's going on until finally you break through, and then the rest of the puzzle comes to pieces in your hand like a snowball that you squeeze. Thank you for watching. We will be back with more tomorrow, and we'd love it if you'd join us then. Bye for now.